getting the value of A, so it's 2 into 5 plus a B equals negative 2, so this one becomes 10 plus a B equals negative 2, bring this on this side, so B equals negative 12. So that will be our answers which we have to get. So after getting the values of A and B, substitute back in the remainder, which is R of X equals to the value of A, which is 5x plus, since here we have got negatives, is minus 12. So that one is the answer of the remainder which we get, because here they say find the remainder when this one is divided by this, when the function p of x is divided by this. So since here we have x minus 2 and x minus 3, and all of them are dividing the same function, what we do, since here they have given us that this one times this, that means when you divide this one alone and also this one alone with the other equation, what you get will be the same after when divided by the product of these two. So that means the answer which you have got is the answer for getting after dividing by the product of the two. So this will be our remainder which we have to get about that number. So having finished that one will take us to another thing which is related to this, which is we are going to prove something. So we are going to use the same procedure. I think let me write it also here, that can be, okay, mirror of this. So they are saying that given that, so let me use this one. They are saying that given that the polynomial, f of x, the polynomial f of x equals the quotient of x times the divisor of x, then plus r of x. So here they have given us what we are using. So let me write it here that f of x equals the quotient of x times the divisor of x plus r of x, which is the remainder. So they are saying where q is the quotient, then d is the divider, and is the divider, and also they are giving us that the divider, that is d of x, is the same as saying x minus alpha times x minus beta. So that is it, and they are saying r of x is the remainder, that one we know. So they are saying show that what are we showing? That the remainder of x is given by x minus beta, times the function of alpha, times the function of alpha, then plus x minus alpha times the function of beta, all over alpha minus beta. So that's what they want us to prove, that that one is given by that. So now how can we prove this? We said what we must first know is how to deal with these things of the product. When they say the product, this one is the divisor. That means each of these ones is a factor of that function. That means we do everything individually. That means everything is given its own remainder. So having got that one, so we are continuing with the solution. So on the solution part, this one becomes, from what is being given, that function of x is given by the quotient of x times the divisor of x plus the remainder of x. So that's what we have, and that is what they have given us. Also that the divisor of x, equals x minus alpha into x minus beta. So we said when it is like this, like from the other example which we have seen earlier, that when we have something like this, we do everything individually. And also what we must first know is that we say that when they give you the function f of x, and they say this one has a remainder, we say that when you substitute in this one, you shall find that after substituting the values of x, calculating in the value of x, you shall find that the value of x which we have substituted, assuming x minus m was equal to 0, so we say x is equal to m. So when substituting here, and f of x will be f of m, which will give us the remainder of that x which we have to get. So the function which we shall get, or the remainder, or the answer which we shall get after substituting that value which is being given, will be the remainder. And also we said that the remainder of x is given by a plus c, it is ax plus b. So that's what we must first know, which will help us when you are doing this question. So we are continuing. So for this case, I'm going to say when x minus alpha equals 0, so I get also x in terms of alpha, which will give us x equals alpha. So after getting that one, so I have substituted this one, so which we have that our f of alpha equals, from what we know that before we write this one, we saw that our f of x will be equal to the remainder of x. So this one will give us clear that our f of x is the same as ax plus c plus b. So this one will help us when calculating these things. So since here we have said x is the same as alpha, so we can substitute. Here we say that our f of alpha equals a alpha plus b. So this one will be equation 1. So after getting the equation 1, we continue on the second one when x minus beta equals 0. So our x will be equal to beta. So after getting it in terms of beta, so it's said that f of beta equals a beta plus b. A beta plus b. This is equation 2. So after getting the equation 2, since we have here subtraction between the two, we have subtraction, what we can say equation 1 minus equation 2. Since this is subtraction, we are seeing here subtraction. So that means we need something of a subtraction kind. So we say equation 1 minus equation 2, which will give us clear because it is alpha minus beta, of which our alpha is the first and beta is
the second equation.
So for this case, after writing that, we subtract. So this one will be this minus this, which is f of alpha minus f of beta, which will give us, so what we do on the left hand side, also do it on the right hand side, so which is a alpha plus beta, so minus a, and this is b not beta, a beta plus b. So that's what we have, which we have to get. So now what we do, we have to open the bracket, so which will give us f of alpha minus f of beta, which will give us this one and this, which becomes, since this one is a alpha and a beta and a is common, so we shall say is a into alpha minus beta. Then this one, it is a positive, so since this one is positive, also this one will change to become positive, which will give us a 0 when we add the 2. So after doing that, so we make a the subject. So our a will be equal to f of alpha minus f of beta out of alpha minus beta. So that is what we have tried about that. So after getting the value of a, we see from the other example, we saw that after getting the value of a, we have to substitute in either equation 1 or equation 2. So we can let us put in equation 1. Okay, put in 1. So it will be now f of alpha equals the value of a, which we have got, which is f of alpha minus f of beta out of alpha minus beta, then times the value of alpha, and then plus the value of the b. So by doing this, we have to get the value of b. So that one becomes very clear. So we take this one this side, so which will give us f of alpha minus, so when you take this one to the minus f of alpha minus f of beta out of alpha minus beta, so times alpha equals b. So now after getting it in terms of this one, then what we do, we have to get the remainder now. So we say the remainder is the same as this one. So since we say the remainder is the same as the function f of x, so that means f of x is the same as the remainder. So that means we shall say from f of x, so here we can write from f of x equals r of x. So that means r of x is the same as ax plus b. So after doing that, so we are going to substitute in this remainder, in the equation for the remainder, we get now the value of the remainder by substituting the value of a and b. So substituting in the value of a and b, this one will give us something like this. So when we put the value of a, which is f of alpha minus f of beta out of alpha minus beta, so times the value of x, then plus the value of b, which is f of alpha minus into bracket f of alpha minus f of beta out of alpha minus beta, then times the value of alpha. So let me put this one here. So here, since here it is f of alpha, so minus alpha into that one. So now after getting that one, we have to continue so that we can get this in which they want, the remainder of that expression. So it must be that form, and it must be very, very similar. So it must be the same. So after getting that one, they are saying that our remainder now of x will be equal to. So we have this one. What we do, we first here get the LCM and work upon with this. So we have to work upon, first deal with this one here, the value of b, which is here. So this one will give us that it will be f of alpha minus f of beta out of alpha minus beta. So plus, here it is times x. So if it is times x, so this one will give us, when you multiply this one by x, because we affect only the numerator, which is x, f of alpha minus x, f of beta. So that is what we have. So we say plus. Now we are going on the other side. So we get the LCM is alpha minus beta. This one becomes all over. So we are getting now the LCM is that. So this one divided by this. So which will be alpha minus beta. So times f of alpha. So it becomes here minus. So it is minus. We are